In allergy season, you might not be able to see what makes you sneeze, but you sure can sense it. So you know something's there, and since pollen often causes allergic reactions, that might be the culprit. If we look at how many pollen grains are in 1 gram, we can better understand how minuscule they are. There are about 30,000 grains of pollen in 1 gram. That's a lot of zeros. But there's a way to write such great numbers without so many zeros. Scientific notation. It uses exponents to help us express this number. 30,000 has 5 places in it. The ones place is to the right. Each of the other places is worth 10 times the value of the next place to its right. So, an equivalent expression of this number is 3 times 10 times 10 times 10 times 10. Another way to write a number multiplied by itself is with an exponent for the number of times the number appears. So when you combine all the repeated 10 times, you get 3 times 10 to the 4th power. Writing the number that way is scientific notation. Scientific notation uses a number of 1 or greater, but less than 10 times the power of 10. So we can say that 1 gram of pollen contains about 30,000 grains, or that it contains 3 times 10 to the 4th power grains. See how it's easier to write than with all those zeros? It has other advantages too. Wipe the pollen from your eyes and let's take a gander at more examples using exponents and scientific notation. Money doesn't grow on trees, but it can grow into more money. If you want to invest $100 in your friend's new hip cafe, she'll offer you a 5% return for 5 years. That means you'll earn 5% of the original value in the first year and 5% of new values each added year. 5% of $100 is $5. So if you don't take out your gains at the end of year 1, you can expect your investment to be worth $105 with a gain of $5. That's 1.05 times the original value. The original value plus 0.05 times it. That's 100 plus 0.05 times 100, which is 1 plus 0.05 times 100, or 1.05 times 100. You can continue this step-by-step approach for the remaining 4 years to find out your ultimate return. Each year, your investment is worth 1.05 times the value from the previous year. After 1 year, it's worth 1.05 times $100. After 2, it's worth 1.05 times 1.05 times $100, and so on. But you can write the same thing more simply using an exponent. An exponent is the number of times a base number is used in a multiplication. If you do the calculations, you'll find that 1.05 to the 5th power equals 1.2763. So after 5 years, your original $100 has grown to that times 100, or $127.63. That's making some money. The human body has fascinated ancient and modern scientists alike. Even though it's one large mass, our body's host to a multitude of microscopic cells. You hop on the doctor's scale to determine your overall body mass. But how do you express the mass of things too tiny to register on that scale? One way is with scientific notation. We can use scientific notation to represent virtually any rational number, and it can help us compare very large or very small things. Scientific notation is a way of writing any number as a number greater or equal to 1 and less than 10, multiplied by a power of 10. So you can use it to express the weight or mass of your whole body in pounds or kilograms, or ounces, tons, milligrams, or micrograms. Or you can use it to express the mass of teeny tiny cells and parts of cells that make up your body. Powers of 10 are used in scientific notation. The exponent on the 10 tells us how many times the base number is used in a multiplication. Let's go inside the human body. The average adult has about 5 liters of blood, or roughly 5,000 grams. Meanwhile, a single red blood cell's mass is about this number of grams. We can write these numbers in scientific notation. The exponent of 3 means we multiplied 10 times itself 3 times, which is 1,000. But what's the negative exponent? That means it's 1 divided by the base to that power. So 10 to the minus 11th power is 1 divided by 10 to the 11th power. So this is a very low number, close to 0, but not as near as 10 to the negative 20. But 10 to the negative 20th power is even lower, nearer to 0, than 10 to the negative 11th power. DNA is our genetic code. You can think of this molecule as containing our body's blueprint in a way. DNA's vital info determines how our cells function, develop, reproduce, and ultimately determines traits like height and eye color. Despite how fundamental DNA is to our lives, it's so tiny that we need an electron microscope to see it. So how can we describe something as small as DNA's mass in meaningful units? Scientific notation is a useful tool. It can represent low numbers in a condensed form. A number written in scientific notation is expressed as a number greater than or equal to 1 and less than 10, multiplied by a power of 10. Since you can't put DNA on a human-sized scale, we use molecular mass. In standard notation, a molecule of bacterial DNA has a mass of this number of grams. Look how much less than 1 it is. Scientific notation's a simple way to express this very low number. Let's see how. A number raised to the negative power is the inverse of the number raised to the same positive power. This is the basis for the low numbers in scientific notation. So 10 with a negative exponent is the same as 1 divided by 10 to that power. It tells you how many places to the left to put the decimal point. Follow the place value pattern. An exponent of negative 1 is the same as 1/10 equals 0.1. And an exponent of negative 2 gives us 1/100th, which is 0.01. We can convert this number into exponent form by moving the decimal point 15 places to the right. For each place we move the decimal point to the right, we have to represent the exponent of 10 as a negative number 1 less than for the previous place. So the scientific notation expression is 1 times 10 to the negative 15th grams. See how scientific notation makes it easier to express and read this number than in its standard notation shown with all the zeros? Remember, that's about the mass of 1 molecule of bacterial DNA.